In this problem, we are being asked to find the complex zeros for a polynomial function. Then we are asked to write that function f in a factored form. Our function is f of x is equal to x cubed minus 6x squared plus 16x minus 106. First, we can identify the number of complex zeros or the maximum number of complex zeros for this function by noting that its degree is 3. So the degree of this polynomial is 3, and that lets us know that there are at most 3 distinct complex zeros. Now, to begin, we have integer coefficients for each of our terms. So we can then apply the rational zeros theorem. And applying that, we are going to begin by listing out all the possible combinations of factors for our constant term, which is Rp. So Rp will be equal to the negative 106. And if we want to list all the factors of that, we're going to think of all the values that can go in and divide. One method I tend to use really in the very beginning, I will just list factors like 1 times 106, 2 times 53, and so on. The reason I like this method, the good thing about it, is just you go through, like say you get to 3 and 4, you go, because if you're not sure, you can continue listing them. And then I think it's around 8 and 12 where it begins to switch. So let me show you what I mean. I'm going to double check this real quick. Take 106 and we divide it by 8. It doesn't go in. You get around 13, right? 13 something. I just want to demonstrate, if you haven't had me for, say, a factoring class previously. 9 gives you 11, right? And then, I mean, obviously 10 is not going to go in. So let's try 11 again. And now you get back to 9 something. So I see it's basically like when you start circling back around. So that was 11 something. 10 we know does not go in. And then, you know, once you get back to 11, like if you put regular 11 in, then you get 9 point something. So we've circled back around. You've listed all the factors. The only remaining factors as you go back up to 106 are going to be 53 and 106. And I just like to point that out in case maybe people aren't sure how to be sure that they've listed all the factors, okay? So that tells me for my P, possible values are going to be, we're going to do plus or minus 1, plus or minus 2. We'll have plus or minus 53 and plus or minus 106. So we use our constant term or our a sub 0. We look at the polynomial notation in order to find possible values for that P. Next, we will look for possible values for our Q. And for that, we use the term from our the term that created our degree, like our highest power, and or like our a to the n. So if our degree is 3, our n is 3, a to the third, or a sub 3 with x to the third. Let me say it that way. In this case, our q is just 1. So that really just gives us plus or minus 1 for our q values. All right. And now we'll create the ratio P over Q for those, and that's going to give us our first root or our first 0, okay? Possible values for it. So P over Q, we get plus or minus 1, plus or minus 2, plus or minus 53, plus or minus 106. Now to determine which of these values are going to be the root, we want to enter this expression or like our given polynomial into our calculator and identify where it's crossing our axis. Now I did this a little ahead. I will warn you, this was a little tricky because these are some large values. So I may just walk you through real quick how we can kind of play with the calculator to figure out what the window is best on these, because these are kind of big. So let's just start off. We're going to go to our calculator and enter our polynomial. So we have x cubed minus, and here I'll even do that for you just to demonstrate. we've got x cubed minus, did I write this down? Let me see. Oh, I have it. Okay. Yeah, make sure you have it written down if your screen's going to go away, right? It's minus 61. I'm sorry, 6 x squared. Oh, no. X cubed minus 6 x squared. And then it's plus 61x. And last, we're going to do minus 106. All right. So if I don't know anything about it, I typically start with just like a Zoom standard. No, this is going to be, or so we already know that 10 by 10 is not going to maybe give us the best shape. So let's do a Zoom fit. Yes, okay. That's probably going to be your best option when looking at something that's kind of unknown. This is an excellent window. Let's go ahead and look and see what they did for us. We have negative 6 to 6 for x, okay? It's going up by 1. Our y scale is, I found about negative 1,000 to, I think I did about 400 and up by 200. So they, like, it took me a little while to get there. So Zoom fit's definitely the way to go on this one. That's a pretty good window. Now, looking at this, remembering, if you're not sure, always go back to your window. Our scale, because we're looking for where our value crosses the x-axis, is it's a scale of 1. Coming here, it looks like it crosses around 2. Now, 2 was one of our possible zeros. So what we're going to do next, we're going to do this by hand, but we can also do it here on the calculator. If you go to second in calc, we want to test our predicted zero. So if we put in, actually let's do value. We're going to do the value of x when it is equal to positive 2, where we believe it crosses. If you hit enter, you're going to have y is equal to 0. Okay, so we have the calculator plug that value of 2 into our function. We're going to do it here on the video as well. So I'll just scoot down a little bit, trying to keep my function in the picture. Although I did find it written down, which is helpful. That's okay, we can come down. So we're going to say, based on our graph, we predict that it's going to be x is equal to 2, right? There's a 0 at 2, let's say it that way. So say 0 at 2, right? So we're going to just double check that numerically within our function. So plugging in f of 2, and remember, it's always advisable to use parentheses when plugging in a value, evaluating a function or an expression with a given value. You're going to retain your operations by doing that. And then that also helps you, because this is how you would want to enter it if you were going to type it into a calculator. So go ahead, you can pause the video if you'd like, type it in your calculator and verify that indeed you do get a value of 0. So this is 1, 0 for our function. And we can use that value then, along with either long division or synthetic division, to further factor our degree 3, this is a 4-term polynomial. And using synthetic division, we'll be able to rewrite that in terms of a binomial and a trinomial. And then we'll be able to use other methods to continue to factor it all the way down. Okay, so now that we have that value, we can go ahead and complete synthetic division. So synthetic division, we're going to take our 0, that is 2. We're going to place it here. I'm going to take the values that I have above. So again, my equation was x cubed minus 6x squared plus 61x minus 106. I'm going to place the coefficients for each term inside the box here. I'm going to leave space to write a number. So like I can put a number here, but I'm not, just to give you an idea of how big it needs to be. And then underneath this, I will write the column values as I come down. So I'm not going to place a number here. I'm going to bring my 1 down first. And now I'll start completing the process of multiplying my 2 by 1 to obtain 2. Adding down the column, I get negative 4. Multiplying 2 by negative 4, I get negative 8. Adding down the column, I obtain 53. Multiplying 53 by 2, I get 106. Okay, this would be our remainder column if it did not evenly divide. We do not expect to get a value here because we've shown that that's a 0, so it should evenly divide. It's a factor. X minus 2 should be a factor of, and I'll put a note here with that. Because that's a 0, that implies that x minus 2 is a factor. And now we know from this that our next factor in trinomial form will be x squared minus 4x plus 53, okay? And we can then write our equation up above. It's been factor sum. So we've now simplified it a little bit. We have x minus 2. And then we have, 1 second, okay, good. X squared minus 4x plus 53. We're not quite done. You know, we want to continue going until we have identified all the zeros. So we have the 1 0, that's 2. And that's equivalent to this factor of x minus 2. Now for our trinomial here, if we can, we'd want to try and factor it just using like simple factoring strategies. 53, that's not going to be able to be done in that manner. So we will go ahead and use the quadratic equation on our depressed equation of x squared minus 4x plus 53. We will find its zeros or solve it by using the quadratic, that's actually formula. Keep saying equation. So just to review, the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So plugging in, I'm going to make a little line here, a little bit bolder, just so I don't get confused about what some of these things are. Excellent. Okay, we have x equals negative 4 plus or minus. I'm going to take that negative 4 and square it. Minus 4 times 1 times 53 all over 2 times 1. Moving down a little bit. I'm going to extend my line as well as I go just to kind of knock it a little bit bigger. A little bit bigger. Okay. Just not to confuse some of this work. Then we're going to have x equals 4 plus or minus. And this will become 16 minus, let's do 53 by 4. Okay. See what we get. 53 times 4 gives me 212. All over 2. And again, just continue to simplify until, I'm starting to run out of room. This will then give me plus 4 plus or minus radical of, what is 16 minus 212? Okay, I get 196. It's going to be negative over 2, which then simplifies down to 4 plus or minus. The square root of 196 is 14. So it's going to be 14i over 2, and that further simplifies to 2 plus or minus 7i. So we now have all 3 of our zeros. So if I scroll back up to the top here, we now know that our zeros, so I'll just list them right up here. We now know our zeros are equal to, we said 2. I just forgot what I wrote. It was 2 plus or minus 7i. Okay, good. 2 plus or minus 7i, or even better, let's list them out individually. 2 plus 7i, 2 minus 7i. And then those transfer over into a factored form of, let's do this. We had x minus 2, so it's going to be x minus negative 2 plus 7i, and x minus, are those negative 2? I think it was positive 2. I'm sorry, I said negative. I was thinking about the sign there. 2 minus 7i. Good. Now, we will want to go ahead and simplify this. That's our last little step here. Not too bad after all the work we've done today. So our final factored form would be x minus 2, x minus 2 minus 7i, and x minus 2 plus 7i. All right, let's take a step back and look at all this wonderful work we've done. Excellent. Okay, so just to review, we had a polynomial for term. We've been asked to find its complex zeros. We used that rational root theorem because everything here was an integer. We found the factors for our constant term. We found the factors for our leading terms or highest degree. And then we found the ratio of each of those values. We looked at the graph of the function in our TI 8384 calculator. And looking at that graph, it looked like it crossed at 2. We verified not only with the calculator, we also did it by hand to ensure that 2 was indeed a 0 for this function. Once we had it, we were able to take that one factor, synthetic division allowed us to factor that using x minus 2 or our 0 at 2 to obtain the trinomial, the depressed equation. And once we have that depressed equation, we just use the quadratic formula to identify the two remaining complex zeros. We rewrote the zeros up here just so you could see them all together. And finally, we put it in the factored form as requested within the problem.